discuss the chapter Application of Integrals. So the chapter for the day is Application of Integrals. Motive behind this YouTube channel, that is Math Universe with Dr. Naseer Ahmed. In that motive video, I gave an example how I'm going to cover, and the example was with respect to chapter matrices. So many will be wondering, so to upload matrices, and after linear programming problems, he is directly starting with application of integrals. Dear student, don't forget, we have got less time and we have to grab more marks, and one such small chapter is application of integrals. I do understand that in chapter number 7 you have got integrals, which is a combination of both indefinite and definite integrals, and you have too many formulas. But this chapter requires 4 to 5 formulas, and if we are perfect with that, with those formulas, then things will be very simple. So let us first try to list out those formulas, and if you are perfect, then 5 marks is assured. So the first formula will be, so let's go for list of formulae. The first formula is integral of root of a square minus x square. I'll be talking about indefinite, definite in detail when I take the chapter number 7, integrals. Now only what are the formula we require, that I'm going to write it out and you are going to memorize that surely. So just see this. It is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a plus c. Be careful, there is no negative term here. Students, for writing the formula, they are going to have a doubt plus minus sign. Just see there. For this first term, plus sign. Second term also plus sign. And then plus c. This minus is again with the same. Okay. Whatever the term we have got, minus x square same. And whatever we have got, same term is again written. So, the second formula is integration of sine x with respect to x is cos x plus c with a minus sign here. Third one is integration of cos is plus sine x plus c. One more, integration of x power n with respect to x is x power n plus 1 divided by n plus 1. Be careful, the power of x is both n plus 1 there, okay, n plus 1 plus c, and n should not be equal to minus 1. Actually, for n not to be equal to minus 1, there are two reasons. Reason number 1, if I write n is equal to minus 1 here, okay, I'll get this x power minus 1 plus 1 will be 0, x power 0 by 0 I will get. X power 0 is 1, but this will be 0. So it will be 1 by 0, which will be what? Undefined. This is first reason. With respect to, one of this I can say, with respect to our usual way of writing the function f by g, denominator g should not be equal to 0. But the actual reason is, if I put n is equal to minus 1 here, no, I get x power minus 1 with respect to x, this. Now, this is 1 by x, and the integration of 1 by x is log mod x. That's the reason we give the condition n should not be equal to minus 1. But anyway, this formula, we are not going to use it, okay, for this chapter. One more formula is integration of a constant with respect to x will be k into x plus c, where k is a constant and it can be any real number, okay. So these 5 formulas we are going to use from indefinite integral. Coming to definite integrals, we are going to use one formula, that is fundamental theorem of calculus, to be specific, integral calculus. So what it says, okay, fundamental theorem of integral calculus. Now what it says? It says that if I know that indefinite integral of small f of x is capital F of x plus c, then the definite integral. Now how to know whether the given integral is definite or indefinite? You can see there is a number a here and one more number b here. This we call lower limit. Okay, and this we call upper limit. So whenever we see in the integration sign lower limit, upper limit, that we call definite integral. And what this says is that when you are going to integrate whichever the function f of x is there in definite integral, after you get the answer, you are going to write in place of x the upper limit b minus the lower limit a. So this we are going to use throughout in our chapter application of integrals. Regarding the derivation on all this, when I take chapter integrals, there we are going to discuss this. Okay, but presently I want you to memorize this 5 along with this. Then with this, no, we can think of aiming high from this chapter. One question for final board examination under the section part D for 5 marks it will be there, and in all the 3 model paper in part D we have got this question. I mean to say question from this chapter. Okay, now let us start with the concept of the chapter application of integrals. You can make a note. Students, having understood all the basic formulas which is required for this chapter number 8, application of integrals, let us now move on to understand the concept behind this chapter. So this chapter is going to give you the application of integrals as the name suggests. Here the integrals is going to give us area under simple curves. So here we are going to find area under simple curves. Now the question mark is, which are those simple curves? Those simple curves are circle, ellipse, parabola also is there, trigonometric functions sine and cosine. So to this extent NCERT has covered. Now let us understand the concept first. So just see carefully. Let us consider the coordinate axis. Or let I erase this. Let it be a good graph. Now see, I am considering the coordinate axis, x and y axis here. As we know, they are mutually perpendicular to each other, and this point of intersection is origin. Let us consider a curve. I have used the word curve. I have not used the word function. So it can be any curve. So this curve equation is given by y equal to f of x. So here most important thing to be understood is this curve is in terms of only one variable x. It's not in 2 variables. And this is we call explicit. Y is equal to f of x. I'm writing y in terms of x alone or with some constant. Right? F of x, it contains all the terms in terms of x along with the constant. Now here let us have a vertical line. Now what is vertical line? Any line perpendicular to x-axis. And one more line, again a vertical line. This both line, this line and this line, both are perpendicular to x-axis or parallel to y-axis, and this we call vertical line. What we call vertical line. Any line perpendicular to x-axis or parallel to y-axis. Now why it is required? See, when we talking about area, no, first we should have boundary. If you don't have boundary, then area will be infinite. So here, this particular area is bounded by the curve y equal to f of x, and this is a vertical line whose equation I will take as x is equal to a, and this is x is equal to b, and this line can extend below x-axis also, okay? And presently I am confining myself to first quadrant. Now I want to find this area. How are we going to find this area? Listen carefully. What we are going to do here is, we are going to take small vertical strip. Just see here, a very small vertical strip. Now I am taking a bit bigger here so that it is visible for you, and let the concept be clear. So this is actually very small, okay? But I have taken a bit bigger so that you can see. Now see, we want to find the area of this. Recall from school days, what is the formula to find area of a rectangle? So coming to area of the rectangle, if I say this is my length and this is my breadth, so area of the rectangle is what? Length into breadth. This concept itself is applied here. So mean to say that here, this vertical strip which is taken, we want a rectangle. You can see here a line, this is also a line, this is also a line. So here is a curve, you will say yes, definitely. Now what we are going to do is, the tip, let us suppose this is A, this is B, this is C, and this is D. Here I am just going to draw a perpendicular from this line AD to BC. When I am going to draw, you see perpendicular here. Now you can see that this ABCD, okay, this, let I give some name for this, A, and here let us say, suppose I will take E here. So AECD is a rectangle. Now you see here, some of the area is not covered. This is the area. So I'll do one thing. I will try to give magnifying. I'll try to give a magnifying for this. So what is happening here? Just see this part I'm magnifying here so that it is clear for you. So the curve is like this, and we have two lines, and this point A, B, E. Let us make it here. A is here, B is here, and from here to here it is E. Now see carefully what has happened. When I have drawn the rectangle here, when I have drawn the rectangle here, some area is neglected. That is this area. Which one? A, E, B. This area is neglected. Okay, first point. Now what we try to do is, that's the reason we are trying to take very small width. Now let us suppose that width is dx and the height is y. Okay, and now we are going to only compute the area AECD. So first point, what I want you to understand, as I said, some area is neglected. Even if I take very small distance, suppose this distance dx, I'll take very width, I'll take very small. So if I take very small also, you see some area is neglected. Again take small, some area is neglected. Surely even if you go for a minute case, some area is neglected. First point what I want to address is, from this approach we will get approximate area whenever it is a curve. For polygon we get exact area. Okay, point number one. Now point number two, how to get that formula? Let's try to discuss. Now see carefully, I have taken y and I have taken dx here. You might also think why you have taken y here, why dx? It could have been some other also, mean to say this could have been y and this could have been dx. For this to understand, let us go to very elementary level of your school days. See carefully what I am trying to explain here of your school days. If I take any point here, P of x comma y, see here, I have dropped a perpendicular PA on x-axis. Similarly from here, one more perpendicular on y-axis PB. Now for a while, think that you are present here and you are going to go down. I am going to down. I am just going to reach to x-axis. So I am here, from here. I am starting the journey here, I am here, I am here, I am here, I am. So this value is what? Decreasing. The length PA is decreasing, and this line is parallel to y-axis. So this length will be given by y coordinate, because as you are decreasing, you are here, you are here, you are here, you are here, and any point lying on y-axis is of the form 0 comma y. So this is given only by y-axis. That's the reason this will be your y coordinate. Similarly, if you for a while think that you are present here, now you want to walk over this line towards y-axis. So you are here, you are here, you are here. Slowly you are moving. So what is changing? See this? It is here, x-axis. So the x coordinate is changing. Okay, and why it is happening? It's a rectangle. You can see OAPB is a rectangle, and opposite side of rectangle is what? Equal. And any point lying on x-axis is of the form x comma 0. So x will be changing here, not y. So this is parallel to this. So here, this is your x. So always this width is y. Sorry, this width is x and the height is y. That's the reason I have taken y and dx. Here I have taken a very small elementary width, so dx. Okay. So let us proceed now with this. So I hope that concept is clear. Now I want to find, now like this we are going to divide many small widths. So here again, very small width we are going to take here, but it will be equidistant. Now then, if I just talk about this particular area, as per our school days, length into breadth. Length is y, breadth is dx. So y into dx, and this whatever is there, I will take this as some elementary small area dA. So that is given by here. But I don't want only this area, I want this entire area which is present. This entire area, let's try to give some name. Let us say the name A, B, C, D is already used, E is used. Okay, so let us name this some other marker F, G, H and M. So I want to find this entire area. So which area we have to find? Area of what? F, G, H, M. And this area will be given by, see, we have some all the area. So since I said sum, limit sum, so it is integral from where to where? Starting from here till this. So A to B. So A to B. And since each of these are rectangle, length into breadth, nothing but this y into dx. This how you get the formula. Now what is y? Y is f of x. So integral of a to b f of x dx. So this will be the area of this, and this we call vertical strip. So whenever I use henceforth vertical strip, you should be able to recall this concept, and the area is integral a to b f of x dx. In this, the area is bounded by x-axis. So whenever the area is bounded by x-axis, we'll surely use vertical strip. Okay, x-axis, then the outlet x is equal to a, x is equal to b, and the curve. Now let us also try to understand one more concept. Now it did not happen that always my curve is bounding x-axis. It can be also bounded by, the area also can be bounded by y-axis. Let us suppose the curve is something like this, and the equation of this curve is x is equal to g of y, and I am going to have the horizontal lines here. Now what is horizontal lines? What is horizontal lines? Any line perpendicular to y-axis or parallel to x-axis. Okay. Now the equation of this is given by y equal to some constant. Let us suppose the constant is c, and here it is some constant d, and there is an area again present. Now same, the way we went vertically, we drawn the strip, small length in this area. Now here also a small horizontal strip we will write. Okay, I have just drawn horizontal. Now again here you see, again I am going to use rectangle area concept, and here some area is left out. Again, if you want, I can go for better, we will understand perfectly. Magnify this. Before we magnify, let us name them. So let us say that is again, this is A, this is B, this point is C, this point is D, and here I have taken E. So when I magnify this, I am going to have the magnification of this. See carefully, curve is there, and here, and one more here. So this point I have taken as D, and here it is C, and here it is E. And since I am saying rectangle, so there should be a line perpendicular. Now you see here, this area is again neglected. Now since this area is also neglected, we are going to have approximate. See, when I say approximate, no, please understand, don't come to a conclusion then why we are studying. The area will be varying very less, not too huge. The word approximate means too less. Okay. Now like this. Okay. Now this is the rectangle now. Which one? A, C. I mean to say A, B, C, E. So again for this as rectangle, length into breadth. So that here my breadth is x and the height which is present to here is dy. So again area of rectangle is length into breadth. So it is length into breadth. Fine. Now, so here the breadth is x and length is dy. And like this I want to find all these small strips whichever is there. For that I am taking integration. And it is C to D. Okay, C to D, the boundaries. And that will give the area. Okay, just like that. Area of what? Let us name this some other color. So A, B, C, D is mentioned. Let I give again the same here also. Okay, let I give some other letters. M is done. So N, P, R, and this is S. So N, P, R, S. This is R. So N, P, R, S. The area is given by. So area of N, P, R, S is given by integration C to D x dy. And here I want you to understand, when I'm writing A to B, don't forget x is equal to A to x equal to B, and it is also, you can see from here dx. So this will be always x is equal to A to x is equal to B, and this will be y is equal to C to y is equal to D, and this we call horizontal strip. We should know the things by name. That's very important. Okay. For example, what is my name? Dr. Naseer Ahmed. So you should know the things by name, not just know. You just know some concept. And here x. What is x? G of phi. So here I just want you to also understand one more point. What? Since we are going to integrate with respect to y, my integrand, nothing but the term to be integrated, should be in terms of y alone, and the constant also can be there. Similarly, since dx is there, my function should be in terms of x alone or a constant. Okay. It also means that when you are going to have the problem, surely it did not happen that they have already solved for y or solved for x and given. We are the one, after plotting the graph, we will see whether the area is bound by x-axis or y-axis. Depending on using vertical strip or horizontal strip, we are going to solve either for y or for x. But for this, graph knowledge is important. So anyway, all those 3 questions from the model paper and 2 questions from NCERT text, totally 5 I will be trying to cover, and all the graph will be given. Okay. And I also understand some student will be thinking, why so many concepts, means why sir is going for so detailed. Don't forget, I have said you, my target is not only this. Surely I have to go for CET aspirants also and JEE aspirants also. So for concept I'll be saying watch these videos. Okay. Just I want to move ahead. I don't want to again repeat the things. Okay. Now see carefully one important thing here. Here it is first coordinate, due to which both x coordinate and y coordinates are what? Positive. Due to which I have not taken x and y mod. For both I have not taken mod. Because now what I'm trying to say is, when I go for second, third and fourth, x and y is not always positive. So thinking about that, I am going to use modulus for both. Okay. Now as soon as I have spoken about this, one thing is very sure, student doubt will be, sir, let it be the vertical strip or horizontal strip, you have confined yourself to first coordinate. Yes, my dear student, I have confined to first coordinate. So I will take 2 more cases. where we are going to discuss in second, third and fourth quadrant. Now before I go ahead, why we have taken to first quadrant, let us try to understand again in elementary level only. Let I not write here, it will be too much in that. Now just see here. Again, see, you should have this habit, no? We should always go to our elementary level, school days. We also have got no slogan, school chale hum, like that. See this, whenever we talk about any coordinate, it is x comma y. So here it is plus comma plus. Here in this is first quadrant. Coming to second quadrant, minus plus. Coming to third quadrant, minus minus. Coming to fourth quadrant, plus minus. Okay, write properly, plus minus. So what I'm trying to convey a message here from school days, elementary level. Always let us write any coordinate. First coordinate is always x, second is always y. Now you see, always our curve is of the form y equal to f of x. Means for different values of x, we are going to get different values for y. Okay, now? So always you see in the first quadrant and second quadrant, y coordinate here positive and here also positive. In short, whenever any curve is present above x-axis, I repeat, any curve present above x-axis, it will be always positive, as you can see from here. So when curve is positive, the area will be also what? Positive. So here and here, I have taken, actually than saying first quadrant, now I would like to say above x-axis. So as soon as I have taken above x-axis, surely this and this area should be positive. Whereas you see, third and fourth quadrant. In third quadrant, you see y coordinate negative and here also negative. Since both in third and fourth quadrant, y value is negative. So y equal to whatever the curve you will get, it will be what? Negative. So since it is negative below x-axis, than saying third and fourth, I would like to say the word below x-axis and above x-axis. For first and second quadrant above x-axis, and for third and fourth quadrant below x-axis. So for below x-axis, the y value is negative, above x-axis the y value is positive. Hence always whenever you see any area bounded by the curve above x-axis, the area will be positive, below x-axis the area will be negative. So this, let us try to discuss two more cases under integration. From elementary part I have made you understand. Now how to deal with integration, what should be the extra precaution to be taken by us. Okay, fine, let us erase this. First you make a note of this. Yes, now let us move on to the next two concepts, where the third case which I want to discuss. Just see the graph carefully. Than saying 101 things, no, than saying 101 thing, it's better to give the picture of that. Now you see, I have got a region here, okay, area here, which is below x-axis. I mean to say from, let us say here, x is equal to a to x is equal to b. Okay. Now I know as soon as I write x equal to a, many will think, sir, a is negative, no, because x-axis is here, so I should write minus a, no. See, understand one thing. I do understand that from school days, it is mentioned that whenever sign is not mentioned, it is positive. Correct? Just a small correction for you people, that if it is a particular number, I mean to say, surely in school days also same thing they said, but the thing is, no, we won't give that much of precaution to what is said. See this, if I write only 5, and I make it here, if I write only 5, is it positive or negative? Positive. Why? There is no sign given to here, so plus it is, so positive. So it is positive. If I write minus 5, 5 is a number, known number, and what is the sign here? Minus. So it is negative. But if I give you only x, now is it positive or negative? You will keep quiet. X is a real number. X is a real number. Sir, how can you say real number? Don't forget, apart from the chapter complex number of first PUC, remaining all are real valued function. Nothing but my codomain and domain will be set of real numbers or subset of real numbers. Okay? Until and unless not specified. Okay? and here we all are dealing with real numbers. So when I say x, now even one more thing you see now. For example, if you take this equation, for example, okay, and if I say to plot or solve, okay, for x is equal to one number, let us suppose you take 1. So y is equal to 1 plus 2, what? 3. If I take x is equal to minus 3, now see, when you put here, you will write y is equal to minus 3 plus 2, y is equal to minus 1. Now, what I want to make you understand from here, no, when doubt is there that there is no sign given for a should be positive, just come here. For this x also sign is not given. Then how come x is taking here positive, all will be happy? But you see, x is taking negative value. Why? X is any real number. It can take positive also, negative also. So please stop that whenever you have got any variable, any constant also given to you, don't comment that it is positive or negative just by seeing something written here. No. We have to specify in the question, a is positive or x is positive. We have not specified anything, then we will just keep quiet. It's just a real number. Okay. So now I want to find this area. This area. Again, this area is bounded by which axis? X-axis. And again, I'm going to use vertical strip only. But this area is below x-axis. So surely this area will be negative. Area will be negative. Let us say that I will take this area as A. So my area A is negative. So I will be finding this area by taking a modulus sign, and it is integral from where to where? A to B. And this curve equation is y equal to f of x. So again I will write here f of x. Again, I don't want to recall what I just said, vertical strip and horizontal strip. Directly I'm writing, okay. And since this is below x-axis, I should have surely what? Modulus. Okay, modulus. Why modulus? This entire term will be negative, but area cannot be negative. So we are taking absolute value, nothing but positive, or I can say non-negative value. Okay. Now here is the case where it is below x-axis. Now one question might come, sir, what if it is area is bounded below x-axis also and above x-axis also? For that, let us take this last case. Let I erase this. See carefully. Now moving on to the fourth problem, means concept. So now you see the graph which I am going to take. I have got something like this. Now you can see some part is here. So again, x is equal to a. I am going to stop it here. Let us suppose some b. Then here one. See, I am just writing that point. I am taking one point here where it's a point of intersection between the curve y equal to f of x with x-axis. I'm not just randomly taking here any point. Only point of intersection between the curve and the x-axis. Similarly, you can see here also. Because as soon as it crosses the x-axis, let it be below or above, the area sign will change. Okay. Now you see this. Here it is C, and here it is, suppose it is D. Now I want to find the area. Now see, let I take this as let I name the areas. Okay, it will be clear for us. This entire area is A1. Okay, this entire area is A1. Whereas this entire area I will take as some A2. Okay, and again I'm not taking any minus or plus. As I said, no, that whenever I won't write, it's understood. Okay, let I not again say that. Then here it is. Let us use some other color. A3. This particular. Fine. Now see carefully when I want to find this area. So I want to find the area. That is try to find entire. Okay, area of the shaded region. Let I just comment in one line. What's that? Area of the shaded region. This region is given by, from where to where? See, this one area I want. So A1. Then this area will be A2, but I will give mod because it will be negative, and this will be A3. What is the meaning of that? When I want to find the area, I will not write A to D. No, we are going to write first for area A1, which is above x-axis, A2, this point of intersection. So let us draw a vertical line here at the point of intersection, and this is x is equal to B, and here also one vertical line at the point C, x is equal to C, and already I have got a vertical line here. Let I extend that, x is equal to D. So now my areas will be integral from A to B, A to B, and this area curve, this area is bounded by the curve f of x, then plus B to C, f of x dx, plus C to D, f of x dx. And since this particular definite integral is pointing the area below x-axis, surely what I should give? I should give a modulus. So this is how you are going to take the problem. It is bounded both below and above x-axis. So coming to the concept, we have completed all the concept of this chapter. Now comes the problem. See, since I have given you this two concepts where it is below x-axis and above x-axis as well as below the areas, I am thinking to take the problem in the reverse order. Mean to say in the model paper, no? Question number, okay, I will just write, but 5-marker question, as you know that only one question from this chapter is there, which is of 5-marker. There we have got sign graph in model paper number 3. So let I take sign graph first, so that this concept which I have said is still more clearly understood, and also we are benefited with 5-marker question. So let us take that as the first question. So I will erase this one and we'll go for that problem. Okay. Dear students, now time has come to solve the questions of 5-marker from model question paper 3, 25-26 academic year from KSEAB, and this is under part D. As you know, part D is a 5-marker question. Yeah, 5 I have mentioned already. And the question says, question number 44, find the area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi. So let us try to draw the graph of this. So see here, we have y equal to sin x, the curve given, the curve equation, x equal to 0 and x equal to 2 pi. Now the curve here, the sin x curve, x-axis, y-axis, x dash, y dash, 0, graph of sin x. Oh yes, it can good, fine. So now what here, this is the curve of y equal to sin x, and I have to find the area bounded by this curve from x equal to 0 to x equal to 2 pi. Now y has stopped here because this will be 2 pi, and this is anyway 0, and here you can see point of intersection with the curve and the x-axis. So this point is 0 because sin pi is 0. Okay. Now, as I said, we'll go for that concept. Just see carefully. This particular area and this both are bounded by x-axis. So I can use vertical strip. So vertical strip will be applied for this area as well as for this area. For vertical strip, as we know, it will be with respect to x. So required area, let us write it here. So I am not writing shaded area, required area or shaded area, no problem, is equal to, see, this is from this line, this is y-axis. What is equation of y-axis? It is x is equal to 0. And then you may ask, what is the equation of x-axis? For just for curiosity, this is y is equal to 0. For this problem we are not going to use this, but just for knowledge sake. Now there is a point of intersection. Again, draw a vertical line here, and this point is x, since point is pi comma 0, so vertical line x equal to pi, and lastly here it will be this point x is equal to 2 pi. So let us start one by one. Just see carefully. Okay. Now it is integration from where to where? 0 to pi, and this curve is given by sine x dx with respect to x. Then plus it is from pi to 2 pi, this particular area. So it is pi to 2 pi and then sine x dx. And this particular area, since lies below x-axis, and this area is represented by the second integrand here, second integration here. So I will be taking what? Modulus. And I will try to give modulus in this blue color, so that thing will be there. And as per this concept, since this is below x-axis, this should be surely what? Negative. Let us see that. Now what is integration of sine x? It is minus cos x. I asked you to memorize this formulas at the beginning of this chapter video. Then plus as it is, integration of sine is again minus cos x, and it is between here pi, pi here it is pi to 2 pi. Now again for this, what? Modulus will be given. Now many students will be thinking, sir, both are same, no? So surely both should have same value, and some student will be thinking, sir, minus is there here, so this will be also negative, no? Sabar, have patience. Let's try to complete the problem. We'll see. We'll get all the answer by end of this solution. So here modulus is given. Now it is try to apply lower limit and upper limit by fundamental integral calculus concept which I gave you at the beginning of this chapter. So minus out a bracket, upper limit is pi, in place of x pi here, minus lower limit is 0, again in place of x it is 0, plus this minus as it is cos here, upper limit is 2 pi, so in place of x 2 pi, okay, then minus lower limit is pi, so in place of this. Now just see carefully, this minus should be multiplied for this, so this minus is for the entire item. So purposefully I didn't give a bracket to make you understand. See, this minus is to be multiplied to the solution obtained after simplifying upper limit minus lower limit. Many students will not give bracket, due to which this negative will not be multiplied here. So better be careful with this type of error, and practice is required. So now I'll take modulus for this. Now let us recall some of the formulas of first PUC. What is cos pi? Here it is there, so minus 1 it is. What is cos 0? It is 1. Even cos 2 pi is also 1. So let us apply one by one. So this is cos, let's write it here. Cos pi, okay, minus out first. Cos pi is minus 1, then minus cos 0, from here it is 1. Then plus of minus out cos 2 pi, cos 2 pi is 1, then minus cos pi is minus 1. Okay, now again I will give what? Modulus. Let us simplify. Minus 1 is minus 2. Let us go ahead. Minus 1 is minus 2. Then here minus 2 minus plus 1 plus 1 2. So now see carefully what I am getting. Minus 2 into minus is plus 2, whereas here minus into plus is, first this plus as it is, this plus as it is, minus into plus is minus, and it is under this modulus. Now can you see, before I comment the answer, I got negative minus 2 because the area is bounded below x-axis. So mod of minus 2 is plus 2. So the final answer will be 2 here, and mod of minus 2 is plus 2. What is 2 plus 2? 4. So 4 square units. So the area bounded from 0 to 2 pi is 4 square units. Okay. So you can see the whatever the concept is set, because this is below x-axis, and you can see that calculation is here. See, this one part is here, then this simply is here. Under the modulus, very clearly you can identify. Now coming to now coming to the other approach, for which you will get for that approach of 5 marks. Let us take that. So if you don't want to go and memorize this so many, or the other way of solving, the alternate for which you can get marks. Let us take that also. And after that I am going to discuss one question to have one more enlightenment. Okay. See, so the alternate solution of this alternate solution, and you can go with alternate as well. Again, so I will write solution. So it should start from here. See carefully. Again, the curve I will draw for you, sin x curve. So small graph. Yeah. So 0 to 2 pi, and this is again pi. Same graph I have drawn, no, bit smaller, because as I said, I want to discuss one small point. Okay. Now see carefully here. This curve is again sin x only, and the question is from 0 to 2 pi. Yeah, this is x equal to 0. This is the equation of, this is y axis, this is y axis, the equation is x equal to 0, and I can draw one vertical line here, so x equal to pi. Whatever the area is, this same area is here also. So in place of finding 0 to 2 pi the way we have did here, we can just go like this, 0 to pi. Here I am shading this. Okay, so I can just say, since this area and this area both are same, I repeat, this area and this area both are same, so I can just write the solution as area, better required area, is equal to 2 times of shaded region. So whatever region area you are finding, multiply by 2. Why 2? There are two areas and both are same. So again it is a vertical strip because bound by x-axis. So this line is given by x equal to 0, the y-axis. So 0 to, and this is vertical line pi, and the curve is sin x. Sin x, yeah. Now from here, what is integration of sin x minus cos x? Apply the limit 0 to pi. Now 2 times of minus, again I will keep as it is. Okay, so now I will take a flower bracket to distinguish this two bracket, cos pi minus cos 0. So as already discussed, let us write the again reason here. Cos pi is equal to minus 1 and cos 0 is 1. So having this, will get 2 times of minus. What is cos pi? Minus 1. Cos 0 is 1. What is minus 1 minus 1? Minus 2. Minus 2 minus plus. So you can see ultimately you got positive. This 2 is from here. This is from here. This is from here. This is from here. And this is representing this particular area which is above x-axis. And again we got positive only. 2 2s are 4 square units. And that's what we got previously also. And I would suggest you can go for this only. Okay. And surely, no, even if it is CET also, etc., I'll give some other concept that time. But let us suppose I got a problem bounding below and above, and I know that from symmetry that both the areas are same, then I would like to go for this type of approach than going for this. But here the thing is, I wanted you to understand the concept clearly. Okay. Now, one more thing. Just see carefully. Now, this solution is completed. It is one important point to be highlighted here. Okay. Not a part of above solution. I am writing problem is completed, but some point within just 1 minute will cover. Sir, what will happen if I won't break the integral? And what I want to say is, in definite integral, one question will be there like this. Evaluate. Let us talk about this question. What is integration of sin x minus cos x? Then apply the limit from 0 to 2 pi. Minus out. Upper limit is 2 pi. So cos 2 pi minus cos 0. What is cos 2 pi? Already we discussed here. Cos 2 pi is 1 and cos 0 is also 1. So again I repeat, cos 2 pi is 1 and cos 0 is 1. So I can just say here that cos 2 pi 1, cos 0 1. 1 minus 1 will be 0. So we got 0. Now what I'm trying to comment, listen, first of all, why we got 0, whatever the amount of area is covered here, same amount of area is covered here, but this is positive and this is negative, so it will be what, 0, as the areas are same. Now the question is, sir, is this working wrong? No, it is correct. Then what about this two working, sir? This is also correct. Then why the different in this answer? Understand, whenever the questions definite integrals are being given and they have not mentioned the word area, then this is the procedure. We are not going to bother about whether the curve is below x-axis or above x-axis. They have just given an integration, definite integration. We call this a definite integral because limit is given, and just you have to find the value of the definite integral. We will be least bothered whether the curve is bounding below x-axis or above x-axis. Okay, so this I want you to understand. And now because of this we can also answer why it is 0, because whatever the area is there here, same area below and both are same. Make a note of this. So that's it. Again, this is not a part of this solution for this question. Fine. Yeah, one more thing, you can just take one assignment on this. In place of sin x, you can take the assignment as y equal to cos x between the same 0 to 2 pi. Okay, and again you will get answer to be 4. It is there in example of the NCERT text. You will get 4 only. Same way.